So the first thing we have to do is choose an object to isolate. It's asking us for um, a force that's acting on the floor, which kind of lightly suggests that maybe we'd want to isolate the floor, but that doesn't make much sense. And if you tried to draw a free body diagram of part of the floor, it would become very clear that that's going nowhere. I mean, um, for one thing, this is sort of a practical thing to consider, like whenever you're doing problems in a class or from a book or whatever. You can't isolate anything that you don't know the mass for, you know. So you're not given any masses associated with the floor, so you have no way to calculate weights. So that sort of hints strongly that you want to isolate the box. So then in the end, we're going to calculate a force on the box by the floor and then use Newton's third law to figure out the force on the floor by the box. So free body diagram of the 20 kilogram box. So there's the outline. There is a weight of 196.2. And then the forces that are applied to the boundary are the 30 Newton force here, the 100 Newton force here, the 50 Newton force here. Any other forces? Yep, that's right. There is friction, so this is a unknown vector. So we have a force vector F on the box by the floor, or whatever subscripts you want to use there, but the first one should represent this box. Second one should represent the floor. Now we can go to Newton's second law, but we have to first figure out, express these in component form, because all the Newton's laws are going to be in terms of vector components. Okay, so the 100 Newton force, if you put the tail at the origin of a coordinate system, we know that the direction, the unit vector, is going to be the cosine and sine of an angle that goes counterclockwise from here to here. There are other ways to do it too, but this way always works. So, and we know that this angle is 30. The reason we know that angle is 30, this is one of those SAT type geometry things where this is the angle that's given, but these, I can't remember what they're called, vertical angles or something. They're called something. They're definitely called something. And this red angle is equal to this black angle. Okay, so the angle that we want here is, you can think of it as all the way around 360, but not quite. It's 30 degrees short of that, so 360 minus 30 is 330. So the force vector is the magnitude, 100, times the cosine of 330, sine of 330. And so you get a force vector of 86.6 and negative 50. And now the same thing for that 50 Newton force. Put the tail at the origin of a coordinate system. This angle is 45. We want the angle that goes all the way from the positive x counterclockwise to here. So that's 180 plus another 45, so 225. So the force vector is 50 times cosine of 225 sine of 225 and so you get minus 35.35 minus 35.35. And now you can plug everything into Newton's second law. And remember, every one of these forces, 1, 2, 3, 4, there are 5 force vectors in this free body diagram. So you're going to be adding 5 force vectors together on the left side of Newton's second law. So we have 86.6 negative 50 plus negative 35.35 negative 35.35 plus the weight force is 0, negative 196.2. The 30 Newton force is in the negative x direction, so that's negative 30, 0. And then the last one is the force on the box by the floor. So I'll break that up into components like this. And those have to equal the 0 vector. And so now we have 2 equations for the 2 unknowns, the 2 components. You can think of the x component as equation 1, the y component as equation 2. And if you solve that, you get that the force on the box by the floor is equal to negative 21.24 newtons, positive 281.56 newtons. But we didn't want the force on the box by the floor. We wanted the force on the floor by the box. So Newton's third law says the force on the floor by the box is equal to positive 21.24, negative 281.56. Any questions about that? Okay, well, so we'll do a few more. We're pretty much through now with, we're through with all the stuff that you need to work on all the practice problems for the exam on Thursday. I'll do one more example problem that's related to the exam first thing tomorrow, and then we'll move on to rigid bodies.